Today I'm going to talk about Einstein's 25 general relativity mistakes. And actually there are a lot more than this, but that's all I could fit on the board. To begin with, mistake number 1 is the 27 plus mistakes that I talked about in my special relativity talk about Einstein's 27 greatest special relativity mistakes. And those he basically started with failing to acknowledge the quantum field is there, failing to acknowledge the wavelengths and frequencies of the quantum field, give the quantum field dimensions and clock rates instead of space, and space itself actually doesn't have dimensions and clock rates. From there, he kept on making more and more mistakes that multiplied because he ignored the quantum field and what it brings to physics, which is everything. So number 2, the foundation of general relativity is matter increases the van der Waals torque of the quantum field. And if you watch some of my other videos and you're aware of the Casimir Effect, then you know that the Casimir Effect is caused by an effect where the quantum fluctuations are being eliminated from the area between two plates, which causes the plates to be pushed together by van der Waals forces. The van der Waals forces pushing the plates apart are lower than the forces pushing them together. Van der Waals forces exist between electric charge dipoles. And in a sea of electric charge dipoles, there's also quantum van der Waals torque. And it's the torque that regulates the polarizability and magnetizability of all these quantum fluctuations that form the electric and magnetic fields of electromagnetic theory. So 3, van der Waals torque increases the permittivity and permeability constants. By increasing the resistance to polarization and magnetization of space due to this torque. And this torque isn't some optional physics thing. Whenever you have a sea of dipoles, you have a van der Waals torque, and it's very commonly studied in chemistry when you're dealing with electrically charged materials, but people don't apply it to the quantum field when they have to. It's physics, it's real physics, you have to deal with it. And when you include it, you get some very different answers. So then we have 4, the increasing permittivity and permeability decreases the speed of light. One of the foundational equations in physics is that permittivity times permeability is 1 over the speed of light squared. So as the permittivity and permeability go up, the speed of light goes down. This is what happens when light enters a piece of glass and it slows down. And this is what happens when it enters a region of the quantum field that's near a star or planet. Light slows down. And the ignoring of the fact that light slows down near large bodies of matter, or anywhere in the vicinity of matter, which is actually everywhere, but it's more noticeable when you're closer to stars, you get light slowing. So I should have listed that he falsely assumed the speed of light is constant, although I included that in special relativity problems. So 5, matter decreases the speed of light. This is a foundational statement of general relativity. And all general relativity must keep that in account. So 6, light bends due to a changing dielectric constant and changing clock rates. And this is something that Einstein actually realized, that back in 1907 to 1912 time frame, he was working with an electromagnetic form of general relativity. And he calculated the bending of light around the star, assuming the star changed the dielectric constant. And this idea was further developed by Dickey in 1957 and was generally ignored. People didn't want to believe that they could develop general relativity from quantum field interactions and quantum field dimensions and clock rates. So, but this is the reality. This is the real physical reality when you come from general relativity from the perspective of a quantum field theorist. So, 7, light slows due to the dielectric constant and clock rates. So something like the Shapiro delay. And I'll talk about the proofs of general relativity specifically in a video coming up. Something like the Shapiro delay causes light to slow, and the slowing clock rate causes light to slow. So when light passes the sun, it actually slows down. It's a real slowing. It's not like 69 kilometers of space disappears, vanishes. Light slows. And that's actually a much simpler way of thinking about general relativity. And then 8, the increasing van der Waals torque causes red or blue shift of light. So the so-called gravitational redshift is due to the increasing torque the closer you get. The increasing torque causes the wavelengths to shorten. And as the torque decreases for a photon emitted from a star, it gets longer. It redshifts. This is a very simple mechanism, and it's all about the quantum van der Waals torque changes the wavelengths of light. And that causes gravitational redshift. It has nothing to do with space lengthening or contracting. It has everything to do with the torque, the electric torque changing. It's entirely an electromagnetic interaction. Then he also missed that quantum field pressure differentials cause electromagnetic acceleration. And this is because most physicists have been not even trying to explain electromagnetic attraction or repulsion. What happens when two light charges are in space? What pushes them apart? They don't have jetpacks, they don't lose matter, it's not rocket science. They're being pushed. And the only thing in the vacuum of space to push them is the quantum field. So that's what's doing the pushing, is the quantum field. So there's pressure. And this pressure works by pressure differentials, just like the Casimir effect. The Casimir effect is the model for it. That when you have a repulsive configuration of the Faraday field lines, you get a repulsive force. You get an increase in the quantum field pressure between the light charges, which pushes them apart. And between opposite charges, you get a decrease in pressure. And the same thing happens with magnets. The like magnets push apart, the opposite magnet poles are pushed together. And then Einstein didn't realize this, which led to a misunderstanding of what gravity really is. And so 11, gravitational effects, no, like 10. So 10, Newtonian gravity is an electromagnetic force. And he missed that. The pushing between objects, or the differential in pressures, is due to a shadowing effect. This body shields this body from the quantum pressure going this way. This body shields this body from the quantum field pressure going that way. And this causes bodies to be pushed together. And this was first discovered by Fatio in the 1690s, and it's generally ignored today because physicists didn't think to, instead of using the old ether, kinetic gas ether, as the source of this quantum pressure, to use quantum field theory and use the actual quantum field pressure to explain it. But once you use quantum field theory to explain the pressure, then you realize that, yeah, this is how Newtonian gravity works, and it is purely electromagnetic. And so you don't have to say that, oh, there's no real gravity, gravity's not really a force because things magically follow the curve. No. If you have two bodies in space that aren't moving initially, something has to push them together. Something has to cause the acceleration. You can't say that, oh, they start accelerating on their own. No. Something pushes them. You can't have, oh, it just magically follows the curve. No, something's pushing. And what that is a quantum field. So 11. Gravitational effects involving photons are purely electromagnetic. As I described, you get changes in the permittivity and permeability, which change the velocity of light. They bend the light. They cause refraction. So these are all optical phenomena. They're electromagnetic optical phenomena. It's not gravity at all, really. It's just matter interacting with the electromagnetic quantum field. And so all general relativistic effects involving photons are electromagnetic. And this explains the gravitational redshift, the bending of light, the Shapiro delay, and all the related proofs of general relativity that are based on photons. He missed, then, that 12 general relativistic effects are due to variable speed of light and clock rate changes. And if you actually study general relativity, you find there are three terms that give you, say, the bending of light, or half the bending of light. Variable speed of light, space curvature, and clock rates. So there's three different ways that people have accounted for half of it. Now, clock rate variability, we are very confident about because there's great experimental evidence that you change the distance of a clock from Earth away from matter, the clock rate changes. The clock rate gets slower the closer you are to Earth. So we really have a choice about the other half of it. Is it variable speed of light or is it space curvature? Well, if you start with quantum field theory, as I've done here, it's variable speed of light. And if you believe that space magically has dimensions, which can magically length contract, which can magically curve, then you believe Einstein's general relativity. But if you're a real physicist, you have to go back to the basic quantum field effects. And those are that the presence of matter increases the torque, which increases the permittivity and permeability, which changes the speed of light. This is the real physics. And Einstein missed that because he came up with his imaginary space curvature. There's no evidence that space has any substance in it other than the quantum field that could cause space to have dimensions and clocks. And in physics, we can't work with purely imaginary substances. Purely imaginary dimensions and clocks don't work. In real physics, you have to have a physical reason for a property, like dimensions and clocks, to emerge. They must emerge from the quantum field. So space curvature is not physically real, which is another thing he missed. And then he missed it because of that. Space curvature is not necessary to general relativity. You can describe relativity with variable speed of light and with clock rates light. You don't need space curvature at all. And then 15, there's electrically neutral Maxwell force. And this is something else that physicists have missed. If you have a body moving through space, it's limited by the speed of light. Well, the speed of light is a function of the permittivity and permeability of the quantum field. So a body moving through space is interacting with the quantum field in a way that is related to the polarizability and magnetizability of the quantum field, which tells us that there's some sort of interaction that's related to electromagnetism. It tells us that as an object moves through space, it causes the quantum dipoles to rotate. And the quantum dipole rotation causes the object to continue to move in the same direction at the same velocity, which is inertia. So inertia is self-induction with the quantum field the same way that electrical charges move and experience self-induction in the quantum field. So it's electromagnetic interaction. And once you have that, you find that the rotation of tops and gyroscopes are governed by a law, a physical law that obeys Maxwell's equations. The actual force that causes a top to tip upward and not to fall over, that it's being pushed on by the quantum field. And the reason it goes at 90 degrees, when it's accelerated downward, it goes this way and precesses, is because of the quantum field. It's an electromagnetic type interaction that obeys Maxwell's laws. So underlying mechanics is an entire Maxwell's equation that applies to electrically neutral objects like planets and stars. So 16, the neutral Maxwell force causes precession. The precession of Mercury and other planets, it causes the Lentz-Therian effect, and it causes de Sitter precession, and it causes forms of tidal forces between bodies that don't have tides, that don't have water on the surface to change their location. So all these things are explained by a neutral Maxwell force, including the so-called proof of general relativity involving the precession of Mercury. And number 17, he also missed that tangential velocity causes perpendicular acceleration. That as a body is moving in an orbit tangentially to the sun, for example, that there's an inward force, an inward acceleration. And this is like a Lorentz force. And because of this, there's an added acceleration that's added to the normal Fatio-type gravitational force that increases the gravitation of bodies that are in orbits. And this effect is biggest for bodies in faster orbits. So they have a big effect, say, in spiral galaxies. The outermost stars at higher tangential velocities have a greater force pushing them toward the center of the galaxy. And this is what causes the spiraling of spiral galaxies. It's not dark matter, it's a force that physicists haven't acknowledged. And so that's part of the ignoring of the Maxwell force that occurs with electrically neutral objects. Even though we've known about this force going back to the 1890s when Heaviside worked on it. It just had never reached a final form that all the physicists could agree on, so they ignore it and they talk about dark matter instead. Then they also miss number 18, that relativistic mass cannot cause general relativity. And this is pretty easy to realize, that E equals mc squared, so m equals E over c squared. So if the speed of light changes, the relativistic mass changes. But if the mass changes, that changes the speed of light. So we have a case with relativity that increasing mass decreases the speed of light, which increases the mass, which decreases the speed of light, which increases the mass, which decreases the speed of light. So relativistic mass is not really relativistic mass. It's not really mass, and it doesn't really interact with the quantum field causing general relativistic effects. So we can't really use mass in the equation. We have to use some other thing for the amount of matter that's present. Or we have to think of it in terms of rest mass only. And how we want to do this is in the technical details, and it's something that I'm currently writing a paper about, at least partially. So, 19. He missed that all forms of energy do not cause general relativity. He thought all forms of energy cause this effect. Well, they don't. Because relativistic mass can't cause it because of the infinite loop problem. And other forms of energy don't cause it either. It's just matter. It's just the rest mass of matter that causes it. And specifically, 20, all quantum field energy does not cause general relativity. There's a lot of energy involved in the quantum field that's not related to gravity or general relativity. You get the pressure from the quantum field pressure, but that's not coming from all of the energy. That's just coming from van der Waals type interactions that give a inverse square law obeying pressure. So 21. The neutral Maxwell force includes repulsion. So, like the regular Maxwell force, where like charges are repelled, bodies of matter must be repelled too when there's a neutral Maxwell force that explains the speed of light limit for neutral objects and the inertia and the behavior of tops and gyroscopes and the precession of Mercury. Part of that is a repulsive force. And so what that means is 22, Newtonian gravity is the sum of two or more forces. So you have the attractive Fatio effect due to shadowing, you have the repulsive force due to the neutral Maxwell force, and then you also have forces like the tangential Lorentz forces, which cause inward acceleration. So gravity is much more complicated than Newton ever imagined. And that's the reason why we haven't unscrambled how to include gravity as part of electromagnetic theory, because we're lumping so many different things together and calling it general relativity. And in reality, there's a lot of different things going on that we have to account for. Just like there's a lot of different things going on with Maxwell forces when we're dealing with electromagnetic forces. So 23, gravity is entirely electromagnetic. We have the Newtonian component, we have the general relativistic component, and we have the neutral Maxwell force component. But all three of those are electromagnetic in nature. Maxwell forces are electromagnetic in nature. And the neutral Maxwell force follows the electromagnetic principles. And it's related. I will put up another video on matter force and probably do a couple more that are more recent. And then he also missed 24. The equivalent principle is not needed, the equivalence principle. Because we're dealing with electromagnetic force and electromagnetic forces which are equal to electromagnetic forces. And the cause of acceleration due to electromagnetic forces is the same. It's quantum field pressure. It's the same regardless. There's no reason to say that this force is equal to that force when or this situation is equal to that situation, when it's all part of the same thing. There's just one force, the electromagnetic force. And then I'll just throw in a 25th one, that if you have a theory that produces singularities, your theory is wrong. And this is just a mathematical problem. Nature doesn't have singularities. Nature doesn't divide by zero. Not in real physical nature. So mathematicians should have realized that their mathematics was nonsense, because this can't be physically real. And if you start over with quantum field theory and variable speed of light model, you get a different picture where you don't have singularities. So I didn't get into things like black holes, wormholes, etc. that fell out of general relativity, that Einstein didn't really come up with himself anyway. But there's a lot of nonsense that came out of general relativity because the math was bad. So I hope you can see that Einstein made lots of mistakes in his development of general relativity. And in order to fix general relativity, we have to go back and fix all the mistakes. Now, fortunately, physicists have been working on a model of general relativity that meets these criteria, where matter affects the permittivity and permeability of space, which changes the speed of light, and clock rate. So you get a variable speed of light changing clock rate form of general relativity. And this has been proven to be equivalent to Einstein's general relativity without the space curvature in just normal flat space. And so that's what we need to do. As physicists, we need to go back, start over with quantum field theory, redo the basics of general relativity, and adopt a form of general relativity based on variable speed of light and variable clock rates. Well, I hope you enjoyed this video and learned something about general relativity. And if you do, please like, share, and subscribe if you want to watch more of my videos, and I'll have plenty more to say about this. And if you're interested in reading about it, I have some books for sale on quantum field theory. And I'm a retired person and independent researcher, so buying a book helps support me in my retirement, so I would appreciate that. And I also have a Patreon account if you'd like to support me that way. So thanks for watching.